I'm officially recording, guys. Okay. So, does anyone want to pick out one of these problems to work from scratch? From 1 through 6.
Number 1.
Okay, we'll start with number 1. Is there one you would like?
Number 2.
Okay, 1 and 2. So, I'm officially recording, so please no talking. Yes.
Can we go over number 8? No.
We're not there yet.
Okay, we're doing one type of problem at a time.
Okay.
Okay, so for number 1, it says convert 1.6 times 10 to the 24 particles of iron chloride to moles, okay? And of course, every single time, we will be using the triangle to look at the relationship between the given and the find, okay? That is the conversion factor between the given and the find. So, the given in this problem is what? 1.6 times 10 to the 24. By the way, if I make any mistakes, you all catch them. Okay, we're trying to find moles. And, of course, it is the iron chloride. So, you would look at the triangle. You have to have this memorized for the test. This is in many different variations on the test. I'm sorry, I cannot have you guys watching TV, iPads. I'm going to have to ask you to put it away. And especially those who are not doing well in my class. Okay, so the triangle tells us, listen up if you never heard it the first time. All of this is equal to each other, almost like 12 inches are equal to 1 foot, which is equal to however many centimeters. Okay? So, the given is in particles. The find, we're trying to find moles. So, these are the two that we will use for this relationship. Okay? And let's go ahead and write it. For the conversion factor, it's 6.02 times 10 to the 23rd particles. By the way, what makes it a particle? When you look at FeCl3, why is it called a particle, not a molecule or atom? They're all 6.02 times 10 to the 23rd. It's because it's an ionic bond. That's one of the things you need to study for this test. Okay? Anyway, it's equal to 1 mole of FeCl3. Then we're going to set it up, beginning with what was given. We have for the solution 1.6 times 10 to the 24 particles. Okay, and then here, for the conversion factor, which one goes on the bottom? Yes.
6.02 times 10 to the 23rd.
Particles, yes. Leaving the 1 mole for the top. Okay, you would do your math, and your answer should be 2.7 moles of FeCl3. Yes?
My question was, where did the 10 to the 24th and the 10 to the 23rd go? They just go away, once you divide?
They're calculated. It's a mathematical thing. Once you divide this by this, they kind of disappear. Just for this one. Now, if you had multiplied them, if you had the 1.6 times 10 to the 24 times 6.02 times 10 to the 23rd, your final answer would be like 2.7 times 10 to the 47. You see what I mean? So it's just a mathematical thing. Once you punch it into your calculator, it will tell you what it is. Yes? Oh, yeah. We can make it a fraction. I know you guys like to. Yes. Thank you. Yeah, that's a good point. That way you know. You multiply everything in the numerator, divide by anything in the denominator. Okay, let's do number 2. Put that away. Okay, we have 4.1 moles, and we're trying to convert it to particles. You know what? I don't think we should do this one. We just did a similar variation. Like we just did that relationship between moles and particles. Don't you think we should try something with like grams and particles or grams and moles?
3.
Okay, so let's do 3, which has liters, and we're converting it to moles. Okay? So for number 3, we are given 500 liters. We're trying to find moles of HE. The conversion factor, you would have to look at the triangle to see what the relationship is between liters and moles. You look at it, for every 1 mole, it's 22.4 liters of that gas. Okay? So, we can plug it in. Okay? How many liters goes on the bottom?
22.4.
Oh, I actually started the solution here. Sorry. Okay, so the conversion factor was 22.4 liters is equal to 1 mole. Okay, 500 liters. What goes on the bottom? For every 1 mole, you do the math. And for number 3, the answer, 22.3 moles. Okay, let's do another variation. I think you guys need help with number 5 because it has molar mass, and some of you are forgetting that when it comes to molar mass, you're supposed to find the molar mass, which is where you add up all of the atoms from the periodic table. So let's try one of those for number 5. It says a diet soda contains 0.25 grams of saccharin, no calorie artificial sweetener. How many molecules of saccharin are in the drink? So we're looking for molecules, and we're given grams. So the relationship between grams and molecules, okay, is going to be whatever the molar mass of the saccharin is compared to the 6.02 times 10 to the 23rd molecules. Why is it called a molecule? Well, it's covalent. They're all nonmetals. Okay, so let's do this. For number 5, the given is 0.250 grams. The find is molecules. The relationship is 6.02 times 10 to the 23rd molecules are equal to how many grams? Well, we'd have to calculate it, okay? So we have 7 times the 12 of the carbon, so this is the molar mass. We have 5 times the 1 of the hydrogen, plus 1 of the nitrogen, which if you look it up is 14, plus 3 of the oxygen, plus 1 of the sulfur, and I actually don't know sulfur, 32. When you add them up, they equal 183 grams. So the relationship is 6.02 times 10 to the 23rd molecules is equal to 183 grams of the saccharin. Okay, so now we plug it in for the solution. You start off with what was given. What goes on the bottom? Okay, and then the molecules on top. What I want you guys to realize is anytime you have something dealing with grams, you will have to convert it to molar mass, like change it to the molar mass. So every different molecule or particle has a different molar mass. It just depends on what it adds up to. Okay, when you do this math for number 5, your answer is 8.22 times 10 to the 20th molecules of saccharin. Okay, any questions about that? Jacob, do you have any questions? Yes. Yes. Okay, so guys, are there any others you would like to do from 1 through 6? Are we good? Memorize the triangle. There's no other way to do it. And you know what? This is my warning to you. I even am recording this. You will have several questions on this test asking you, like, what is the given in this problem? What is the find in this problem? What is the conversion factor? And what is the final answer? So you have to know step by step how to do these.
Is it all multiple choice?
Yes, it is. Okay? So let's do, then that brings us to number 7, percent composition. Now remember the percent composition formula? You have to know the formula. Go ahead and memorize it. It's up on the board. It's the total mass of the element divided by the total mass of the compound. So you would have to know that before you could do these. Now, they were easy. Mass of element over mass of compound. But what if you had more than one of an element? Let's try it. Let's do letter B because you have 3 of the calcium. So for 7B, you want to know oxygen in Ca3PO4. Okay, so calcium phosphate. What is the first thing you need to do for these? You find the molar mass of the entire compound. Okay, when you add it up, can I just tell you what it is? You guys know how to find molar mass at this point. 310 atomic mass units. You need to know what atomic mass units stands for. Okay, then what part of it is oxygen? We have 4 of them times 2. So how many total of the oxygen? 8. Okay, so that means for oxygen, it's going to be is 8 times the 16, which is actually equal to, I don't even know. I'd have to calculate it. Can anybody do that for us? Okay, thank you. So that means we're going to do 128 divided by 310 times 100, and it gives us the percent of oxygen, which is 41.3%. There's a few of these on the test, so make sure you know how to do them. Lynch? We add up all of these atoms. So we added 3 of the calcium, which I think were like 40 each. For the phosphate, there's 2 of them. You'd look up the mass of phosphate and multiply it by 2. For oxygen, there's a total of 8, so you would add those up. Okay? Okay, I'm going to move on. Now that we've done that, let's do an empirical formula type of problem. Yes?
On the test, will it tell us what's the difference from place to round?
No, but you'll know based on what answers are provided for the choices. Yes.
For part B, I didn't round the molar masses. I just wrote exactly what they were.
Perfect. That's even better.
So I got 41.26.
Oh, okay.
Is that?
Yeah, that's fine.
That was
Yes, that's absolutely fine. Now, on the test, you will have choices, but I can tell you they're not going to be that close. Okay, yes. Shh. Where did I get oxygen? Well, the question on the review sheet, if you look at it for number 7, for letter B, it says, what is the percent composition of oxygen in this? So you take just the oxygens and divide them by the total. Yes?
So what exactly does atomic mass unit mean?
The mass, it's like the unit that we use for the mass of an element. It's something minuscule, something that we made up for chemistry for the sake of these tiny little particles. Okay, let's do number 8. What is the empirical formula for a compound which contains this many grams of iron, that many of sulfur, that many of oxygen? So how would you set that up?